Hello dear friends, welcome back to MACSGATE. We are going to start with probability and statistics as a part of GATE all branches. Of course, especially for GATE DA, Data Science and Artificial Intelligence, because the probability part is subset of probability part of Data Science and Artificial Intelligence. Okay, so let me start with this probability and statistics. Actually, I divided this probability and statistics into three parts. So let me first tell you about this particular classification of probability for your GATE examination. Okay, so this probability and statistics part 1, which is common to all branches. So this particular part is common to all branches. Okay, maybe for some branches some additional concepts may be there, that anyhow you can just go through your syllabus, you will understand. Am I clear? So this is a syllabus which is given for probability and statistics for DA paper. Okay, so actually that particular syllabus is given in a arbitrary manner, so I just divided into three parts so that we can classify and discuss the topic accordingly. So here we are having counting, where we discuss about this permutation and combination, that is counting techniques we are going to discuss. We can also call it as combinatorics. Okay, then we have this probability axioms, sample space events. Okay, then we have this mutually exclusive events, that I generally call it as my part 1. Okay, anyhow I'll be repeating this once again. Then we have this independent events conditional probability, that I call it as second part in my probability and statistics part 1. Then we have this Bayes theorem, which is very important. Then we have this 4 and 5 parts, because it is given in a mixed manner. So I just divide into two parts, like random variables and probability distributions. So where we are going to talk about basic statistical ideas, then we talk about random variables, then expectations, then we talk about probability distributions, the discrete probability distributions and continuous probability distributions, which is common to almost all branches. Am I clear? So this particular syllabus is common to all branches, my dear friends. Then we have the topics which are exclusive for, okay, one second. Okay, so that particular part I missed, maybe. So we have this probability and statistics part 2. So in probability and statistics part 2, we mainly talk about bivariate distributions. So here we are going to talk about marginal distributions and joint probability distributions. We also talk about correlation and regression analysis. Okay, then we have this probability and statistics part 3, where we mainly talk about sampling distributions. The sampling distributions and hypothesis testing. So this is our syllabus, my dear friends, for all the branches. Okay, I mean especially these two parts are exclusive for data science and artificial intelligence. Okay, so first we start with this first part. We try to complete this, which is common to all branches. Then we move on to this probability and stats part 2 and part 3, which is exclusively for data science and artificial intelligence. Actually, the weightage for probability and statistics is very vast for data science and artificial intelligence students. Am I clear? So under this probability and statistics part 1, I just divide the topics like this: basic probability, then we have this conditional probability, Bayes theorem, random variables and probability distributions. See, under this basic probability, I start with introduction to probability, that is today's session. Then we talk about combinatorial probability, that is probability using counting techniques. Then we talk about addition theorem. So these are the three major topics under this basic probability. The first one is introduction to probability. The second one is probability using counting techniques. And the third part is addition theorem. Okay, then we have this conditional probability. We also talk about, multiplication theorem, the independent events, dependent events, we are going to understand them. Then we have this very, very important theorem, which is called Bayes theorem. We talk about total probability theorem and Bayes theorem under this topic. Then we also introduce some basic statistical terms here, okay, which are useful even when you talk about, second part of probability and statistics, third part also. But here we start with introduction of that particular statistical terms. Then we have this random variables. We try to discuss what is discrete random variable, what is continuous random variable. Then we try to discuss the statistical parts or expectations. We try to define expectation. Using the expected values, we are going to define, the mean variance, that is statistical measures of these distributions. Then we are going to talk about some important probability distributions. We have this discrete probability distributions like binomial and Poisson distribution. Then we have the continuous probability distributions like uniform distribution, exponential distribution, and normal distribution. So all these distributions we are going to discuss. Am I clear? So this is about your part 1, my dear friends. Okay. So today I start with introduction to probability. See, if you are live, you have any doubts or anything, you can ask me in the chat, my dear friends. So you can directly ask me questions. Okay, I'm here to answer your questions, right? Please note, this probability you also study in your 10 plus 1, 10 plus 2. I want you to note this point very, very clearly, sir. The probability statistics, matrix theory, and calculus you also study in your 10 plus 1, 10 plus 2. See, some people, they want to do mathematics, means they start with their IIT JEE preparation. Suppose you want this IIT JEE preparation, there are much more better, places where you can learn that, mathematics for IIT JEE. This is not the place. Please try to understand, sir. Okay. Of course, nowadays, there are, many mathematical lessons happening all over, internet. Okay, wherever you find interesting, wherever you find, comfortable, your frequency matches, you can learn there. But please keep one thing in mind. Okay, please keep one thing in mind. Hi, Mokshit Patel. Hello, sir. Please keep one thing in mind. Here, calculus, linear algebra, actually we call it as matrix theory in your 10 plus 1, 10 plus 2 level, and probability. When you study these topics in 10 plus 1, 10 plus 2, that is called learning stage. That is called learning stage mathematics. So when you learn things, we explore all possibilities. But here, the same mathematics, we try to do application. Okay, so this is application stage. Please try to understand. If there are some 10 plus 1, 10 plus 2 students who are listening to my class, it is useful for you as a review. Basic concepts review will happen. Am I clear? But the exploration does not happen, because this is not learning stage mathematics. Please try to understand, sir. If you are preparing for GATE level, you need to understand that. Okay. So if you are an educator, please teach the same manner. The learning stage and the application stage are different. Don't flood with unnecessary things. Okay. So otherwise, what student may feel, if they want to clear, GATE engineering mathematics, first of all, they feel like, they need to clear IIT JEE mathematics. In that sense, people get, depressed. Please don't believe all that, sir. You just need to have overview of the concepts. You need to have overview of the concepts. I can tell you proudly, I've been teaching this mathematics from past 22 years. So I know what questions you can expect in GATE engineering mathematics, and the questions are different from IIT JEE mathematics. There may be some questions you may find in both the places, because the concept is same. That is a learning stage. Some of those questions may appear. Because of that, don't unnecessarily repeat your 10 plus 1, 10 plus 2 mathematics here, my dear friend. That is not the way to learn. Please note this point. Okay, you can learn anywhere. Okay, wherever you find it interesting, comfortable, your frequency matches, your language barrier matches, you go there, you learn, no problem. But please remember the difference between learning stage and application stage mathematics. Here only review of the concepts happens, and those concepts are used for advanced engineering mathematical concepts. Please note. Is that clear? That is the idea. And books, many people ask me which books to refer. There are many books. For the entire engineering mathematics, I generally suggest this Jain and Iyengar sir's books, like, advanced engineering mathematics. Of course, many people say, like, B.S. Grewal, okay, H.K. Das, and there are so many local author books. And if you go for your universities, there are so many, university books are also available. You can take any of those books if you like, no problem. But please note, especially topics like probability and statistics. Okay, the question must be properly defined. Okay, there should not be any ambiguity in the questions. Suppose if you take some bad book where the terminology is not properly given or the question is not properly defined, in such cases that creates lot of confusion. Especially topics like this where there is a chance of ambiguity. See, probability and statistics, if you see the problems, you are rolling dice, okay, you are throwing a coin, okay, or you are throwing coin or rolling dice, whatever. This kind of general problems. You are taking a card from pack of 52 cards. These are the things which you do regularly in your day-to-day life. So in such cases, we may put our interpretations also into that particular problems. And that may create some ambiguity when the question is not asked properly. So please take proper books. Okay, sometimes if you take a bad book, that creates lot of ambiguity. Okay, please be careful. Okay, see, for example, in 2-3 years back or 3-4 years back, I didn't remember exactly, there was a ESC question where they asked a question. Okay, that question is directly lifted from H.K. Das. Okay, but the problem is he lifted it from Iyengar book, which is a standard problem, and only half of the problem he taken. The remaining half of the problem is not copied. And the question was full, but the answer is only half taken. And based on that, the question was asked in the IES examination. And only that half part answer was given as the answer for that. So such kind of things may happen, my dear friends, if you follow certain books. Okay, they are very good books. It does not matter that they are bad books, but there may be some kind of ambiguity. Okay, so you need to be very careful with it, especially with this. And these are the very standard books, like Advanced Engineering Mathematics by Jain and Iyengar is a very standard book for engineering students. Good problems, almost all topics are covered. Okay, then you want some very basic level problems or different variations, you can also go for B.S. Grewal and H.K. Das also, no problem. And there are some advanced books like most of the university student prefer, like Erwin Kreyszig. Okay, and for probability you can take Advanced Engineering Mathematics by Jain and Iyengar. There is a very good book called Mayer book. We always follow this particular book for probability and statistics, sir. Of course, there are so many other books like Gupta, S.D. Gupta, which is very called kind of like a very well-known book for probability and statistics. You can also take that particular book, sir. Okay, so it depends. There is one more book called Sheldon Ross. It depends on your choice, sir. Okay, see, once you understand your concept, you can take any book. It does not matter. Any book does not matter, sir. Okay, so that is about introduction. Now let us start with my probability and statistics part 1. So in today's session, what I am going to discuss, sir, I'll just introduce what is random experiment, what is sample space, what is an event, and I define probability. Then we try to understand what are the axioms. Then we try to understand some very, very important basic results. Then we try to solve basic problems where you try to list the sample space and you try to identify the event which is subset of the sample space, and you're going to find the probability. Okay, so I want all of you to understand this. So things are going to start from very, very, very basic, sir. Okay, it is for all the levels. It is for all the levels. Okay, for all the examinations it is suitable. But if you are preparing for IIT JEE, after learning these concepts, you need to explore more variation. That's it. For GATE, the variations which I discuss more or less are sufficient. Okay, now some people say, sir, I found this problem. If you found one more problem, one more variant, if you wish to do it. There is no restriction. Now, one more thing people feel like, when I say don't unnecessarily do IIT JEE mathematics, if you feel like doing it, do it. There is no restriction. Am I clear? But remember, for GATE mathematics, you don't have to clear your IIT JEE examination. Remember this point. Okay? Please note this point. Let us start with our study. What is random experiment? What is random experiment? An experiment in which outcome is not certain, but it has to be one of the possible outcomes, sir. See, there are some possible outcomes for that particular random experiments. For that particular random experiment, there are some possible outcomes, but in a current situation or in a current iteration or in a current trial, the outcome is not certain. In a simple terms, an experiment is called a random experiment if outcomes are not certain, but it has to be one of the possible outcomes. Please note that point. Outcome is not certain. For example, consider the random experiment tossing a coin. Suppose if you toss a coin, do you know what is the outcome? You do not know. It may be head or tail. Suppose if you know, you should go and help our Indian captain or your favorite IPL team captain, okay, so that you can tell him what is the output in advance. Am I clear? So that doesn't, if you know outcome, it is not a random experiment. Please note that. अगर आपको outcome पता है तो random experiment ही नहीं है. Okay? So if you do not know what is the outcome in this particular trial, then that is called a random experiment. Rolling a dice. Suppose you roll a dice. You know what is the outcome. Some people say, sir, I know. So you are better than Shakuni Mama. Okay. So you should go and help someone else. Similarly, suppose if I take a card from pack of 52 cards. If I take a card from pack of 52 cards, then you know what is the outcome. Suppose if you know, that is not a random experiment for you, and you should try your luck in gambling. Okay, nowadays there are so many places where this is happening. You will get so many ads also, people are doing it. Okay, there you should try your luck. That is, you should try to change your career. You have a better career opportunities. Am I clear? So all these experiments in which outcome is not certain, they are called random experiments. So when you toss a coin, you do not know what is the outcome, but outcome has to be either head or tail. So I know all the possible outcomes, but in this particular trial or in this particular toss, what is the outcome? I do not know. That is random experiment. When you roll a dice, you know the possible outcomes are 1, 2, 3, 4, 5, 6. But in this roll, you do not know what is the outcome. That is random experiment. Suppose you are taking a card from pack of 52 cards. Do you know what card you are going to take? You do not know, but it has to be one of the 52 cards. This is what you call it as a random experiment. This is what you call it as a random experiment. Okay. I think there are 1 second, sir. Some pages are, moving up and down. The next one is sample space. What is a sample space? Now, suppose when you conduct a random experiment, for example, you roll a dice. Suppose you roll a dice. The set of all possible outcomes is what is called as sample space. The collection or set of all possible outcomes is what is known as sample space. Okay. So, what is sample space, Babu? Set of all possible outcomes of a random experiment. The collection or set of all possible outcomes of a random experiment is what is known as sample space. So, for example, if you roll a dice, then what is the sample space? So you call it as 1, you call it as 2, you call this output as 3, you call this output as 4, you call this output as 5, and you call this output as 6. So what is the sample space for this, Babu? 1, 2, 3, 4, 5, 6. So set of all possible outcomes of a random experiment is called what? Sample space. Okay. Now, what about the event? See, event means outcomes of your interest, what you are looking for, outcomes of our choice. Okay. For example, when you roll a dice, you are looking for even number. So this 2, 4 and 6 are the favorable outcomes for that particular event. See, mathematically, event is what, sir? Any subset of sample space. Mathematically, any subset of sample space is event. But technically or general sense, what is an event? Outcomes of our interest. For example, when you roll a dice, and if I am asking for event, getting even number, this is event. And what are the outcomes favorable for this, sir? 2, 4, 6. And this is subset of sample space. So this event, let us call it as E1. And if you observe, this is subset of sample space. See, my dear friend, I'll take one thing. Okay, let me take it as E10. Let me take one set as E10, which is 1, 3 and 6. Can you tell me what is this event? Anyone can try this? Can you tell me what is this event? Anyone can try this? One, 3 and 6. You can try some beautiful name for this, sir. See here, even number. Suppose if I have something like this, you can call it as 135, it is odd number. Okay. Suppose if I write, say 235, it is prime number. Now what about this 136? See, don't worry about a beautiful name for everything, sir. Don't worry about a beautiful name for everything, my dear friends. Okay. Any subset is a sample. Any subset of sample space is an event. If it is subset of the sample space, it is called event. It may be having beautiful name. Here it is called getting even number. Here you call it as getting odd number. Here you call it as getting prime number. Don't try to have a beautiful name for that event every time, sir. So this is an event. This is the event with sample points 1, 3 and 6. Of course, if you want, you can give some other beautiful name, multiples of 3 and 1. Okay, it is an event with 1 and multiples of 3. No problem. That's why also you can define. The idea is event. Any part of the sample space is an event. Any part of the sample space is an event. Please note that point. Now, this is very, very important result which I want you to understand. Okay, suppose you are having a set with n elements. Then how many subset this particular set is having? How many subset this particular set is having? If a set is having n elements, the number of subsets the set is having is 2 power n. For example, if a set is having, say, 2 elements, what are the possible subsets, sir? What are the possible subsets? Empty set, which is set with no elements, or it can have a single element set 1, it can have single element set 2, or it can have element set 1, 2. So all these are subsets, my dear friends. All these are subsets, my dear friends. And how many subsets you are having? 4 subsets. How many subsets you are having? 4 subsets. So if a set is having 2 elements, the number of subsets is equal to how much, sir? How many subsets it is having? 2 square, which is equal to 4. Similarly, if a set is having 6 elements, how many subsets it is having? Number of subsets. How many subsets it is having? 2 power 6. 2 power 6 means what, sir? 64 subsets. 64 distinct subsets. 64 distinct. It is not just subsets, distinct subsets. They are different subsets. Okay, 64 different subsets it is having. Please note this point. Now consider this random experiment rolling a single dice. So you roll a single dice, you may get one of the outputs, sir. Now what is the sample space, Babu? The sample space is you may get 1, you may get 2, you may get 3, 4, 5 and 6. How many elements or what is the size of this sample space? Number of elements in the sample space? 6. So number of subsets, how many subsets this particular sample space is having? How many subsets this particular sample space is having? 2 power 6. Yani 64 distinct subsets. It is not just subsets, Babu. 64 distinct subsets. And please note, each subset is an event. Each subset is a distinct event. So, can you tell me how many distinct events possible? Because what is an event? Event means a subset. So, how many distinct subsets are there? That many distinct events are there. So, how many distinct events are possible, sir? 64 distinct events are possible. See, generally, I ask this question to my students. How many of you know this question? Rolling a dice. So, everyone say, I know this problem, sir. Because most of you might be knowing this. I ask this particular question. See, you need to understand, rolling a dice is a random experiment. It is just a random experiment. In probability, the question is about the event. We are going to find probability of an event, not probability of random experiment. So, if you say, I know the problem of rolling dice means, you should have seen all these 64 distinct events problems. That is, probability of all these 64 distinct events. Have you ever done these 64 events? Have you ever seen these 64 distinct events in your life? Try to write down. Try to write down the 64 events. Because of this, probability looks difficult. Am I clear? See, probability, why it is difficult, sir? If you simply roll a dice, on that, I can create 64 completely distinct problems. I can create 64 completely distinct problems I can create. But if I can start combining them with addition theorem or multiplication theorem, infinitely many problems I can create. So because of this, probability looks very dangerous. Then how to make it simple, Babu? Very simple. Whenever a particular question is asked, first try to understand what is the random experiment. Then try to identify what is the sample space. Then clearly try to see in the question what is the event. In the question, try to see what is the event. Then probability is very, very, very simple. Because out of this sample space, how many are favorable for a event? For example, you are asking for a event of getting even number. This is very simple. What are the outcomes favorable for even number? 2, 4, 6. Suppose if I ask event of getting odd number, that is 1, 3, 5. Suppose if I ask for event of getting prime number. So you just need to understand what is this. If you don't know about prime numbers, the problem is done. What is it? 2, 3, 5. If I ask for getting multiple of 4, what are the multiples of 4, Babu? What are the multiples of 4? Only 4 is there. Suppose if I ask event of getting a number which divides 24. Event of getting a number which divides 24. 1 divides 24. 2 divides 24. 3 divides 24. 4 divides 24. 5 does not divide, but 6 divides 24. See, you just need to understand that event with respect to the given sample space. See, generally, what are the numbers which can divide 24, sir? 1, 2, 4, 3, 4, 6, 12 also divides, 24 also divides. But you can't say 12 and 24. Why? Because you are looking for outcomes which happens when a die is rolled. That is 1 to 6. Out of 1 to 6, which numbers can divide 24? The question changes to that. See, if you understand this, probability is the easiest subject in the world. But if you see this way, then it is the most dangerous subject. And why people make or think probability is difficult? Suppose if I ask, what is probability of getting a prime number? You should think about prime number. Problem is simple. They start thinking about multiples of 3. They start thinking about multiple of 6. They start thinking about multiple of 8. See, if you understand what is the given event, problem is over. But because you all understand this multiples, you all understand this prime numbers, what you do is you try to create a new problem which is not asked and you make it complicated. Don't ever do it, sir. Whatever question is asked, try to understand. Don't put your constraints. So far we are doing very basic level questions. Later on when you talk about addition theorem and multiplication theorem, that is what you are actually doing, like putting some constraints. When you put constraint, the event gets more complicated. You need to understand how to handle it. That's it. First, understand how to see events, then how to see combination of events. That is all about the basic probabilities, and nothing more than that. The entire basic probability is about that. How to identify an event, how to identify combination of events. If you understand the entire basic probability, addition theorem, conditional probability, even Bayes theorem is also done. They are all based on this. How you understand the given events or given combination of events. That's it. And don't complicate the problem by putting your constraints also. They already give some constraints. What people do, they put their personal constraints also into that and they make the problem very, very complicated. So generally what happens, we generally solve a problem. Okay, we explain this is what is given, this is what is given. People ask, sir, what if they give like this? First you have to do this, then some more additional condition. If I apply, what happens? Then you need to understand that. It is as simple as you see. See, if some extra condition is given, if you can handle it with this and this, how to solve it? For example, I want even number and multiple of 3. See, if I say even and multiple of 3, so I want both the condition to be satisfied. It should be even. Even means what? 2, 4, 6. Multiple of 3 means only 6. So both the conditions are satisfied by only 6. So you have to apply the condition. Okay. Later on we see using rules how can you solve this problem. That also we learn. See, here I not started with any probability, sir. I just started with a random experiment. What is a random experiment? In which outcome is not certain, not sure, but it has to be one of the possible outcomes. Then what is sample space? Collection of all possible outcomes. Then what is an event? Outcomes of my interest or our interest or outcomes we are looking for. That is what you call it as an event. Hope the idea is clear. All of you able to follow? Clear? Now let me make it more complicated. 2 dice are rolled. So when 2 dice are rolled, what about the sample space, Babu? Because there is outcome on first day, there is outcome on second day, combination. Okay. So for each of the outcome on the first day, there is an outcome on the second day. So here we are having 6 possible outcomes. For each of the 6 possible outcomes, there are 6 possible outcomes on the second day. 6 into 6, how much, Babu? 36 possible outcomes. Okay. So if you want, you can write down 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, 1, 6, 2, 1, 2, 2, 2, 3, 2, 4, 2, 5, 2, 6 and so on. 6, 1, 6, 2, 6, 3, 6, 4, 6, 5, 6, 6. That is the sample space. So what is the size of this particular sample space, Babu? 36. Can you tell me number of distinct events, Babu? How many distinct events possible, Babu? 2 power 36. 2 power 36. Okay. 2 power 10 roughly 10 cube. 2 power 10 is roughly 10 cube. So 2 power 30 means 10 power 9. 36 means what? 2 power 6. So more than 10 power 9. Maybe approximately 10 power after 1, 10 zeros and more. So that many distinct events are possible. Can you write them in your lifetime, sir? So don't ever think about, completing probability. Okay. Don't ever think about, I know everything, every problem. You will never know, sir. Even the professor who is asking you question do not know all the questions, Babu. Okay. What we know? We know what is the random experiment. We know what is the sample space. If a particular event is asked, you can identify what fellows are favorable for that. This is what you know at the basic level, Babu. Okay. Please try to understand. Don't think that you know every problem. No one knows. You just need to understand the event and identify the favorable outcomes for the event. Okay. So please try to understand this point. Then your probability is always, Babu, simpler. Please note my point. Now let us define the probability of an event. So far I discussed what is a random experiment, what is a sample space, what is an event. Babu, without understanding what is random experiment, what is sample space, what is event, don't try to do gate level mathematics. Okay. So sometimes, people do everything without even understanding what is a sample space, what is an event. But at this level, it is the minimal requirement. See, conceptual understanding, we call it. Okay. This is a basic. They are not difficult. People make it difficult by, introducing so much nonsense in that. They are all very, very, very simple. Sir. Okay. If you want, I'll give you the definition. I'll tell you how you can write it in a more elaborate manner also. Okay. I'll tell you that. Probability of an event. Let S be a sample space and A be an event. The probability of occurrence of an event A is given by. Okay. Probability of event A is given by. So here in the events, okay, you can tell that the outcomes are equally likely, okay, collectively exhaustive, mutually, see, there might be some more conditions people might be giving. At this level, if you understand this, it is very, very straightforward, sir, no problem, because all the outcomes are different. They are different. Because suppose if you are tossing a coin, we are assuming that head and tail occurrence is same. So we say that all the outcomes are equally likely. So if you see proper definition of this probability of event, people might be introducing that also. Okay. So please note that point. Probability of an event is what, sir? Probability of an event is given by favorable number of outcomes for that particular event divided by total number of events. Favorable number of events by total number of events. That is, out of the total number of events, how many are favorable for that particular event is what is called as probability of event A. So we denote it like, number of elements in the event A by number of elements in the sample space. So this is what we call it as probability of event A, Babu. Probability of event A. Is the idea clear? And the probability, whatever you get, that should satisfy the following axioms. Okay. What are the axioms, Babu? The probability of any event must be between 0 and 1. It can be 0, it can be 1 also. That is 0 and 1 inclusive. It between 0 to 1 or 0 and 1. Okay. And probability of this sample space. See, for example, when you are rolling a dice, probability of getting, okay, number less than or equal to 6. 1, 2, 3, 4, 5, 6. That is called sample space. So we call it as a certain event. What is it called, sir? Certain event ya to sure event. This is called certain ya to sure event. Got it? Then suppose you are having two events A and B. Suppose you are having two events A and B which are mutually exclusive. Okay? Mutually exclusive means, for example, suppose you roll a dice. Say the outcomes are So when you roll a dice, obviously the outcomes are 1, 2, 3, 4, 5, 6. Suppose you're looking for an event of getting even number and you are looking for an event of getting odd number. If you see, the outcomes are completely different. So we call these two events as mutually exclusive, disjoint events. Suppose you are looking for a prime number event. Here we are having some common event, common outcomes. So they are not mutually exclusive, sir. They are not mutually exclusive. So they have some common events. There are some common outcomes. So whenever the events are having some common outcomes, if you want to handle probability of the combination of the two events, either this or that, in such case we need to go for addition theorem. But this result which is given here is for mutually exclusive events. The events are disjoint, no outcome in common. And suppose if A and B are disjoint ya to mutually exclusive events, then probability of A or B, how you read it, Babu? You read it as probability of A or B. The probability of A or B is simply given by probability of A plus probability of B. And what is the condition, Babu? They are disjoint. Disjoint mathematically written as their intersection is empty. Their intersection is empty. That is the idea. Is the idea clear, Babu? And before moving on, so probability of any event should satisfy these axioms. Okay. Then we have two important results which we need to understand perfectly. Probability of empty event is 0. We call it as impossible event. Now suppose you roll a dice. What is probability of getting multiple of 8? Multiple of 8 means 8, 16, 24 and so on. They are not possible. So that event becomes impossible. Impossible event. So for any event which is impossible, the probability is 0. That event cannot happen when you roll a dice. That is impossible event. Not only rolling a dice, sir, you can take any other example. Okay. Next comes probability of A complement. So you call it as non-happening of event A. A complement. Some people also write it as A bar, A dash. Different notation people use. I am using AC, A complement. Okay. Probability of A complement. Non-happening of A. Non-happening of A. For any event, probability of non-happening of the event is simply 1 minus probability of happening of A. A means what, sir? Probability of happening of A. P of A means probability of happening of A. Am I clear? So now let us solve few basic problems. See, all these problems are very, very basic level problems, sir. So here we are just trying to understand what is sample space, what is that event. Using the basic definition of probability of an event, you are going to solve it. So here we try to list sample space outcomes, list event outcomes, or understand what is sample space, what is event. We try to visualize clearly and answer the questions. That is basic level probability, Babu. Suppose a fair dice is rolled. Okay, it's not pair, sir, fair. See, dice or die. For single die also you can write dice, no problems. If a fair dice is rolled, then find probability of even number. So even number means what, sir? Getting 2, 4 or 6. See, when a fair dice is rolled, that is the random experiment. What is the sample space, Babu? 1, 2, 3, 4, 5, 6. So let us call this as event even number, as E. So what about outcomes for event E? 2, 4, 6. But we are interested in knowing how many are there. How many elements are there in E? 3 elements. How many elements are there in the sample space? 6 elements. So what is probability of getting even number, Babu? How many favorable? 3 favorable out of 6. So what is the probability, Babu? 1 by 2. That is the probability. Then what about the probability of getting odd number? What is probability of getting odd number? So what about odd number, Babu? Getting 1, 3 or 5. So let us call it as O. Let us call this as O. Event O. So what are the outcomes favorable for this? 1, 3, 5. So how many are favorable for this? 3 out of 6. So that is 1 by 2. Of course, you can also write in decimal format, 0.5. Fractional या तो decimal format you can write down. Is that clear? Clear to you? What about probability of getting a prime number? What about prime number, Babu? 2, 3 or 5. So prime number. How many are favorable? 3 out of 6. Perfect square. What are the perfect squares, sir? 1, 4, 9, 16. But when a die is rolled, only 1, 4. So 1 and 4. So this is a perfect square. Okay. Maybe prime perfect square, let us call it as PS. I'm just giving some name to that event, sir. So 1 and 4. How many favorable? 2 out of 6 are favorable. So what is the probability, sir? 1 by 3. What is the probability? 1 by 3. See, you can create any damn event, sir. When a dice is rolled, I can ask you any question. Okay. Multiple of 3. Multiple of 3 means what? 3 table. 3 1s 3, 3 2 6, 3 3 9, more than 6, ignore. So what are those? 3 and 6. So multiple of 3. 3 and 6. How many are favorable? 2 favorable out of 6. 1 by 3 again. Next, what is probability that you get a number less than 7? Less than 7 means 1 is less than 7, 2 less than 7, 3 less than 7, 4, 5, 6 also less than 7. So less than 7. I just write it like this. Okay, so what are that? 1, 2, 3, 4, 5 and 6. So 6 out of 6 are favorable. So what is the probability? 1. Probability of this event is 1. Therefore, it is a certain event. Ya to sure event. This is certain ya to sure event. Is the idea clear, Babu? Now, what is the probability that you get a number greater than 1? 2, 3, 4, 5. So, how many favorable? 5 favorable out of 6. Now, this is a very interesting question. My favorite question. When you roll a die, what is probability of getting Rajnikant? If you roll dice, you will not get Rajnikant. Okay. So, this is called impossible event. This is called what, Babu? Impossible event. If you roll dice, you are not going to get Rajnikant. Okay. So there is no event which is favorable for this. So 0 out of 6. So probability of getting Rajnikant, impossible. So the answer is 0. Is the idea clear, Babu? Now let us take some more problems. Okay. In a class of 30 students, 20 students play cricket, maybe IPL or some other game, and 10 students don't play cricket. What is the probability of a student picked at random playing cricket and not playing cricket? See here, number of student is your sample space. Number of student is your sample space. Total, how many students are there? 30. How many play cricket? I call it as C as playing cricket. How many play cricket? 20. How many don't play cricket? See, you can say C complement also. 10 don't play cricket. So, what is the probability that a student picked at random playing cricket? He play cricket. So, how many play cricket? 20 out of 30. So, what is the probability, Babu? 2 by 3. Now, the second question is, what is the probability that the student does not play cricket? So, it is 10 out of 30, which is 1 by 3. But I want you to understand the following. This is very important. It is called indirect counting principle. What is it called? Indirect counting principle. See, I want probability of C complement, not playing cricket. So, for any event, probability of non-happening of the event is 1 minus probability of happening of the event. See, it may be a very simple question, Babu, but I want you to understand this. This is very important. Okay, you understand this. Later on, you may do it for some complicated example. Then you understand the beauty of this question. So what is probability of not playing cricket? 1 is the total probability minus probability of playing cricket, which is 1 minus 2 by 3. And what is it? 3 minus 2 by 3, that is 1 by 3. This is indirect way of counting. Please note that. Is that clear? Next question. A box contain chips numbered. So we are having a box which contain chips numbered 3, 6, 9, 12 and 15. That is box 1. So let us call it as box 1. So let us call it as B1. And box 2 contain chips numbered 6, 11, 16, 21, 26. Now here what is that he is asking? 2 chips, 1 from each box are drawn at random. So we drawn 2 chips, 1 from each box. That is, 1 chip is taken from first box and 1 chip is taken from second box. So total possible combinations, that is your sample space, because you taken 2 chips, 1 from each box. So what is the sample space? You can take 3 from first box, then you may take 6 from second box. That is chip with number 3 and chip with number 6. So instead of saying that, I am simply calling 3 from this and 6 from this, or 3 from this, 11 from this, 3 from this, 16 from this, 3 from this, 21 from this. Okay, so instead of writing that all combinations, let us see how many such combinations are there. That is, how many ways you can select 2 chips, selecting 1 from each box are possible. So this is the first box and this is the second box. From first box there are 5 possibilities. For each of these 5 possibilities, there are 5 possibilities from this second box. So what is the answer? 25 possibilities are there. That is, I can take 2 chips, 1 from each box in 25 ways. So what are those 25 ways? If you want, you can just write down 3, 6, 3, 11, 3, 16, 3, 21, 3, 26, 6, 6, 6, 11, 6, 16, 6, 21, 6, 26, 9, 6, 9, 11, 9, 16, 9, 21, 9, 26. Like that, it goes up to 15, 6, 15, 11, 15, 16, 15, 21 and 15, 26. Those are the 25 different ways of taking 2 chips, 1 from each box. Now the question is, the numbers written on these chips are multiplied. So you taken 1 chip from this and 1 chip from this and you multiply the numbers. The probability for the product to be an even number. What is the probability that the product is even number? You want probability for that. What is the probability for the product to be an even number? Okay, see now one way of solving it is, you can identify, you can write down all the 25 and check each product and check which are all giving product even number. You can put in this, product even number event. That is one way of doing it. Okay, the other way is, you can just think about it, how you can get even number, sir. Okay, product, you want product to be even. What are the different possible ways? See, even number into even number is even. For example, 4 into 2 even. Odd into even, also even. 3 into 2, 5 into 4, that is even. Yeah, even into odd also even number. So these are all the combinations with which you can get the even number. But I solve this by other method. What I do is, instead of finding even number, I find product odd. Why I am finding product odd, sir? Because the number of cases where you get the product odd is very less, because odd into odd is odd. So in the first box, how many odd are there? In the second box, how many odd are there? First box, 1, 2, 3 odd are there. In the second box, how many odd are there? 1 and 2 odd. So how many cases for product to be odd, sir? 6 cases favorable for product to be odd. Out of 25, 6 cases are favorable for the product to be odd. Is that clear? So what about the probability that the product is odd? What about the probability that the product is odd? Total is 25. The total we already calculated, and favorable is 6. So 6 by 25 is the answer. Of course, if you have time, no other work to do, you can also try this. Even into even. Even into even means what, sir? Here 2 even and here 3 even. 6 cases. Odd into even. 3 into 3. 9 cases. Even into odd. 2 into odd. Odd how many? 2. 4 cases. 13, 19. Sorry. Okay, but here it is product is odd we find, and it is product is even. And how to get product even, sir? How to get product is even? Because we only got odd, but the question is product is even number. How to get product is even? 1 minus product is odd. 1 minus product is odd, which is 1 minus 6 by 25. What is 1 minus 6 by 25? 19 by 20. See, directly also you can get 19 by 25. This is indirect way of counting. Because this is simple to count, I use this trick. Is the idea clear? There is nothing wrong if you do like this also, sir. So from this you can say what is probability that product is even? What is the probability that product is even? 19 upon 20. Is the idea clear, Babu? Clear to you all? Now comes the most interesting problem. When 2 dice are rolled, what happens? Okay, a pair of fair dice. See, this term fair is used again and again. Don't worry about it, sir. When I say fair dice, all the outcomes are equally likely. That is, probability of getting one number over the other is not more or less. Probability of getting all outcomes are same. Okay, so there is no preference of one outcome over the other, sir. In such cases, the outcomes are equally likely outcomes, and that particular event or that particular experiment becomes fair experiment. That is the idea. In any case, sir, here it is experiment of rolling 2 dice, sir. In any experiment, if all the outcomes are equally likely, then the experiment becomes fair experiment. Okay, that is the idea. A pair of fair dice is rolled simultaneously. That is, 2 dice are rolled. Then find probability of getting sum is equal to 7. So here what I am going to show you is the detail. Then we try to create one very interesting story or one interesting formula or table with which we can answer such questions very quickly. Okay, let us see this. This is one of the very interesting problems, sir. See, when you rolled a pair of dice, so these are the possible things. Okay, of course I have not written everything, sir. So it may happen like you may get 1 on first day and 6 on the second day, 2 on the first day, 5 on the second day, 3 on the first day, 4 on the second day. These are all possible things which may happen, sir. So here is the all possible outcomes. 1 1, 1 2, 1 3, 1 4, 1 5, 1 6. That is 1 on the first day, 1 on the second day, 1 on the first day, 2 on the second day, like that. 2 1, 2 2, 2 3, 2 4, 2 5, 2 6. And so on, 6 1, 6 2, 6 3, 6 4, 6 5, 6 6. See, when 2 dice are rolled, total number of outcomes is, on the first day there are 6 possible outcomes. For each of the 6 possible outcomes, there are 6 possible outcomes on the second day. So 6 into 6, how much? 36. And these are the 36 outcomes. Now, out of these 36, how many are favorable for sum 7? Because when 2 outcomes are there, you can add them. So here I am just doing addition. Later on the question may be product. Later on the question may be about their difference. They can ask you anything. Please try to understand. Okay. See, try to understand the event. Don't just solve a problem, sir. Understand. Then you can solve many more problems on your own. That is the idea. Sum 7. What are the outcomes which can give you sum 7, sir? 3 4, then 4 3. 2 5, then 5 2, 1 6, and 6. So these are the fellows which are favorable for sum equal to 7. For sum is equal to 7 event, this particular event, how many fellows are favorable, Babu? 6 outcomes are favorable, or 6 combination in this case are favorable. So what is probability of sum is equal to 7? favorable, and this is total. Always remember, probability is favorable number of cases by total number of cases. Favorable here is 6 by total number of cases 36, which is 1 upon 6. Is the idea clear, sir? Is the idea clear? Okay. As I told you, I'll give you some very interesting story. Don't worry about it. So when a pair of fair dice are rolled, these are the possible sums, sir. See, I have seen, like, just now we seen sum 7, but when 2 dice are rolled, 1 on first day, 1 on second day, 2 is the minimum sum. What is the maximum sum possible? 6 on one day and 6 on second day. 6 plus 6, 12 is possible. So these are the possible sums. Starting from 2 to 12 are the possible sums. And what about the favorable number of cases? So here I'll give you one simple story. Remember, sir, you can just identify them. 1, 2, 3, 4, 5, and for 7 just now we seen it is 6. So write down 1 to 6, then go down. That is 6, 5, 4, 3, 2, 1. So these are the favorable cases for different sums. You can remember this. Okay. I am also going to give you the idea for favorable number of cases when 3 dice are rolled. Okay. When 3 dice are rolled, for different sums, what are the favorable number of cases? When 4 dice are rolled, for that also I am going to give you the idea, maybe tomorrow. Okay. But please remember, okay, it depends on your attendance regularly. I'll come up with more and more examples, Babu. You will easily understand. Okay. Actually, in my YouTube channel only, you can find out there is one very interesting, I already given that, if you can see that. Okay. Like, shortcut or something I mentioned. Okay. If possible, in the description, I'll provide that. Okay. You can go to that, where I provided when 3 dice are rolled, what are the favorable cases for different sums. Okay. The video description I'll give you, okay, in the comment box. Okay, please go to that. Now look here, sir. Now I can ask you questions. So here I can ask you question like, what is probability of sum is equal to 7? So instead of doing all this nonsense, you can directly know the table. Total, you already know 36 are favorable, total number of cases. Out of that, how many are favorable? 6 favorable cases. Suppose if I ask what is probability that sum is equal to 4? Total 36. For 4, how many are favorable? That's 4, no? 3. Please be careful. Don't see this. This is 4. For 4, how many are favorable? 3 are favorable. So you can easily answer the questions, my dear friend. For anything, what is probability that sum is equal to 12? How many are favorable? 1 out of 36. Is the idea clear? Now I can also ask some combinational questions. But here you see, sum is equal to 5 or 7. See, here I am going to handle the cases where the events are mutually exclusive or disjoint events. Here these events are disjoint. The outcomes which give you sum 5 and the outcome which give you sum 7 are completely different. In such cases, that is, if these two events are disjoint, these two events are disjoint, या तो mutually exclusive. If the events are disjoint, या तो mutually exclusive, in that case, you can directly find the probability like this. Probability that sum is equal to 5 plus probability that sum is equal to 7. Directly I can write that. And I know that always denominator is 36 for both. For sum is equal to 5 or for sum is equal to 7 also, denominator is same. So I am directly writing 36. I can just add the numerators. What about sum is equal to 5? How many cases are favorable? 4 cases. Sum is equal to 7. How many cases are favorable? 6 cases. 6 plus 4. 10 favorable out of 36. You want, you can further simplify 2 5s, 2 18s. And that is the solution. Is the idea clear? This is a gate question actually. Okay. What is the probability that sum exceeds? Exceeds is more than 8. Exceeds 8 means what? Sum more than 8. These cases. That is sum is equal to 9 or sum is equal to 10 or sum is equal to 11. So sum is equal to 12. So denominator is always 36. Numerator 4 plus 3 plus 2 plus 1. What is it? 10 upon 36. So simplifying 5 by 8. So that is the answer. Is the idea clear? What is the probability that the sum is divisible by 4? So these are the sums. So which fellows are divisible by 4? 2 not divisible by 4. 3 is not divisible by 4, but 4 is divisible by 4. 5 no, 6 no, 7 no, 8 is divisible by 4, 9 no, 10 no, 11 no, 12. So what does it mean actually? Sum is equal to 4 or sum is equal to 8 or sum is equal to 12. So denominator is 36, sum 4 3 cases, sum 8 5 cases, sum 12 1 case. So what is the answer? 9 upon 36. That is 1 by 4. So that is the answer. Is the idea clear? Sum divides 36. So which numbers divides 36? 2 divides 36, 3 divides 36, 4 divides, 5 no, 6 divides, 7 no, 8 no, 9 divides, 9 4 36, 10 no, 11 no, 12. So what does it mean, sir? Sum is equal to 2 or sum is equal to 3 or sum is equal to 4, so sum is equal to 6. See, if you understand, no need of writing this, sir. Okay. Sum is equal to 9, sum is equal to 12. So directly denominator is 36. So 1 plus 2 plus 3 plus 5 plus 4 plus 1. Simplify this to get the required answer. 3 plus 3 6 plus 5 11, 12 16 upon 36. Okay. 4 4s, 4 9s. Please check, sir. Okay. Correct only, na? 16, right. So you can ask many questions like, what is probability of odd number? A very common question. It is a very regular question. Odd number means what, sir? 3, 5, 7, 9, 11. So for 3, how many cases are favorable? 2. For 5, 4 cases are favorable. For 7, 6 cases are favorable. For 9, 4 cases are favorable. For 11, 2 cases are favorable. So what is it? 10 plus 18. That is 10 plus 8 is 18 upon 36. That is 1 by 2. You can find what about probability of even number. So you can directly find by this method like 2, 4, 6, 8, 10, 12 or 1 minus probability of odd number also you can do. What is 1 minus probability of odd number? Because just now you solved it, na? You can do 1 minus 1 by 2. Always try to understand the indirect counting principle, Babu. Okay. See, probability does not mean just understanding the events and solving the problems. You should understand what is the event, what is complement of an event. If you can understand these things at basic level problems, you get these ideas when you solve complex problems. Okay. For basic level problems only, if you ignore it, for complex problems, you will never get such ideas. Okay. Please note this point, sir. Okay. You should know this properly. People ask me, sir, how we get these ideas? You never get any idea, Babu. It happens automatically. When you keep on applying these ideas somewhere, that idea comes later on. Okay. So some people, they never use this idea here and they expect they get this kind of ideas for some complex problems. It won't happen like that, sir. It has to happen through a process. What is probability that sum is prime number? Prime number means what, sir? It can be 2, 3, 5, 7, 9 is not a prime number or 11. So now directly write down 1 plus 2 plus 4 plus 6 plus 2. So what is it? 15 upon 36. 3 5s, 3 12s. 5 by 12 is the answer. Is the idea clear? Sum is even number or 5. There is a combination. Even number means Here it is 2, 4, 6, 8, 10, 12 or 5. Either this or this, but there is no combination between them. These are disjoint events. I can see this. Okay. So directly what is the answer? 36. For even it is 1 plus 3 plus 5 plus 5 plus 3 plus 1, and for 5 it is 4. So it is 18. You already seen 8, 9, 10, 18 plus 4, 22 upon 36. See, you can take many more examples like this. You just need to understand the event, then you can solve it. And so far we know how to handle the situation when these two events are disjoint. If there is a combination, then we need to go for addition theorem. We'll see later. Okay. Now, so far we've seen the question where I asked what is probability about their sum of two outcomes. But when you are having two outcomes, you can also have difference. Na? See, here I am talking about difference, means I am talking about absolute difference. Okay, absolute difference. Okay, or you can make it more clear like absolute difference. Okay, please, you have to be very careful with this, sir. What is probability that their absolute difference? Okay, difference. Sorry, there is a printing mistake. Please understand, it's not difference. Okay, there's a printing mistake. See, difference 0, when it will happen, sir? Difference 0, when it will happen? You can just see this. These are the cases. Difference 0, here it will happen. Equal outcomes 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6. So 6 cases you are going to get difference 0. Difference 1, either these 5 or these 5. We are talking about absolute difference. 2, 1, that is if there is adjacent numbers like 2, 1, 3, 2, 4, 3, 5, 2, 5, 4, 6, 5 or reverse. So how many cases? Here 5, here 5. There are 10 cases favorable for this. Difference 2, these fellows. 4 here and 4 here. 8 fellows. Difference 3, 3 here and 3 here. 6 fellows. Difference 4, 2 here and 2 here, 4. And difference 5, this one and this one, 2 fellows. Now what is that he is asking? Difference is 2. Difference 2 means how many cases? 8 favorable out of 36. Total possibility is 36. Favorable for difference 2 is 8. 8 upon 36. So 4 2s, 4 9s, 2 by 9. So same story, sir. Difference. Okay. So difference 2 or 1. See, the outcomes which gives difference 2 and outcomes which give difference 1 are completely different. So it is difference 2, how many cases? Total is 36. Difference 2, how many cases? 8. Difference 1, how many cases? 10. So total 18 upon 36. Okay. But there may be a question. Okay. This can be solved, by listing the elements right now. But if you want to solve it with the formula, you need to wait till addition theorem. So I can ask you a question like, what is the probability that the difference is, okay, maybe 2 or sum is 7. Difference 2, sum is 7. See, difference 2 means what, sir? See, all these cases. You see this and this. 8 cases. But sum 7 means what, sir? Sum 7 means all these fellows. All these fellows will give you sum 7. Correct or not? So I want either this or this. See, or means what, sir? This or both also. So there may be some common fellows. For example, if you see, is there anything common between them? Okay, there is nothing common, I think, right? Nothing which can be common. I think some, maybe difference 1 or sum 7. I think difference 1. Huh? Yeah, I think difference 1. For this, I don't think any common fellows are there. Because there is, sum is not 7 for any of them. Okay, this is disjoint. They are disjoint events. Sorry, difference 1. Let us take this. Difference 1, sum or sum is 7, sir. Difference is 1 or sum is 7. See, not this cases, sir. Sorry for that. Difference is 1, that is these cases. These 5 and these 5. 10 and this 6. So it looks like 16, but if you observe, this is repeated in both the fellows. This is repeated in both the fellows. So that has to be subtracted. So actually, how many are favorable for this? Only 14 out of 36. See, for this, we need to actually use what is known as addition theorem. We need to use what is known as addition theorem. Of course, here, by listing all of them, for example, these 5, 2, 1, 3, 2, 4, 3, 5, 4, 6, 5, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6. 10 you written and this 6. But out of these 6, these 2 are already written. Sorry for that. These 2 are already written. So extra how many? 4 more. So total 14 only. See, this can be solved logically. This simple problem you can solve it logically, sir. But if I ask a different question, sometimes this logical method does not work. You have to definitely go for the addition theorem. Later on, I'll give you such questions also. Okay. So here it may look like we can solve it logically, but I want you to understand the theorems properly. So far, the problems which we solved, where the 2 events are disjoint. So just probability of this event plus probability of this event, because there are no outcomes in common. That is a simple straightforward situation. When there are some outcomes in common, this rule doesn't work. Then you have to go for what is known as addition theorem. Of course, we'll be discussing about addition theorem little later. Is the idea clear? All of you able to follow? So we'll hold it. After our combinatorial probability, we come back to this addition theorem and we'll try to discuss in a more detailed manner. Is the idea clear? Of course, I already done here. So no need of doing once again here. Okay. Right. Of course, when you have numbers, you can also find product. We can also find product. What is the probability that the product is 12? For what outcomes? See, total outcomes are 36. For product 12, what are the favorable cases? Okay, you can have 3, 4, 4, 3. You can have 6, 2, 2, 6. That's it. Any other? No. So 4 favorable out of 36. Okay. Of course, here you can show it here. What are the favorable cases, Babu? 3, 4 and 4, 3. Product is 12. 2, 6 and 6, 2. Product is 12. Only these cases. Remaining all cases, product is different. And one very interesting thing is, if you consider sum, 2 to 12 sums are possible. Difference, 0 to 5 differences are possible. But product, when you consider, all possible products are possible in some range. For example, what about product is 14? So immediately people think like 2, 7, 7, 2. But they never think about 7 is not possible when you roll a dice. So this is never possible. Okay, you can just see this. That is never possible. So this event becomes impossible event. This event becomes impossible event. This event become impossible event. So when you roll dice, what are the possible products, Babu? So the minimum product is 1. The possible products is minimum is 1 into 1 is 1. The maximum product is 6 into 6 is 36. But 1 to 36, all products are not possible. Product 2 is possible. Product 3 is possible. Product 4 is possible. Product 5 is possible. Product 6 is possible. Product 7 never possible. 7 you cannot get it. 8 product is possible. 9 3 3s 9 is possible. 10 5 2s 2 5s. 11 not possible. 12 possible. 3 4s 4 3s and 6 2s 2 6ers. Like that. I want you to verify what are the possible products and what are the favorable cases. So I want you to fill this table, Babu. If possible, you can send me in my Telegram group, CS_Sridhar. In this, you can send this. Okay, please complete that table. I want you to complete this table. It's an interesting question. Now, a pair of fair dice is rolled simultaneously. Two dice are rolled simultaneously. See, so far we are talking about when two dice are rolled, outcomes are there. We can add them. Sum is possible, difference is possible, product is possible. Now we can also have relation, comparison. How many outcomes are favorable, or how many combinations are such that they are same outcomes, equal outcomes. That is, I am comparing with equality, less than, greater than also I can compare. That is the next type of question. What about the probability of equal outcomes? So when two dice are rolled, 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6, 6 are favorable out of 36. 1 by 6 is the answer. What about probability of getting unequal outcomes? What about probability of getting unequal outcomes? See, unequal outcomes means you can write down remaining all 30 will be there, or you can do it indirectly like 1 minus probability of getting equal outcomes. See, I always tell people to try this method. It may look unnecessary sometimes, but I want you to understand, because this gives you idea like we are having an indirect counting. Sometimes it helps and it solve your problems very quickly. Okay, please note that. So again, equal outcomes only from 36 minus, if you remove the 6, 30 unequal outcomes are there. That is idea. Okay. Now look at this. A pair of fair dice is rolled simultaneously. The probability that the outcome on the first dice is greater than the outcome on the second dice. This is a very, very important question, sir. Sorry for that. What about probability? We get outcome on the first die is greater than that of outcome on the second die. So here I just call x1 as the event that we get outcome on the first die, which represents outcome on the first die. X2 represent outcome on the second die. It's not like event, sir. I'm just using x1 to represent outcome on the first die. I'm representing outcome on the second die with x2. So what is that I want? x1 greater than x2. I want x1 greater than x2. So if you observe these cases, we are having x1 is equal to x2. First outcome and second outcome equal. And if you observe this portion where 1, 2, 1, 3, first outcome is smaller than second outcome. And if you observe this, what is happening here? First outcome is greater than second outcome. So you can see total there are 36. Out of that 6 are gone here. 1 6 are gone, remaining 30 are there. Out of 30, 15 are above the diagonal, 15 are below the diagonal. So how many are favorable for this? 15 are favorable for this. How many are favorable for this? 15 are favorable for this. Okay, of course, he tried with a beautiful thing. You can just check that. Okay, that is it. They are for equal and remaining as I explained, sir. These fellows for x1 less than x2. These fellows for x1 greater than x2. That is 15 favorable for x1 greater than x2, 15 favorable for x1 less than x2, and 6 favorable for x1 equal to x2. So what is your question, Babu? What is your question? What is the probability that outcome on the first dice is greater than outcome on the second dice? That is probability of x1 greater than x2. So how many are favorable, Babu? x1 greater than x2 means what? This story. 15 are favorable out of 36. 3 5s, 3 12s. Now I can also ask you question like, I can also ask you question like, what is probability that x1 is less than x2? Which fellows are favorable for that? This is the story. x1 less than x2. x1 less than x2, how many are favorable? 15 are favorable. So for this, what is the probability, Babu? 15 out of 36. 3 5s, 3 12s. See, I can also ask you a question like, what is probability that x1 is less than or equal to? See, less than or equal to. So, less than 15 equal to 6. So, 15 plus 6. So, what is the probability for this, sir? 15 plus 6 upon 36. That is 21 upon 36. And I can also ask you question x1. I think it should be greater than or equal to. Why to ask same question once again? So, greater than, here we are having x1 greater than x2. 15 fellows plus 6 equal fellows, that is 21 only, add carefully, 21 upon 36, 3 7s, 3 12s, 7 by 12. So they can ask you different questions or different combinations like that. Please note that. Okay, now this is one more interesting question. In rolling of 2 fair dice, the outcome of an experiment is considered to be sum of the numbers appearing on the dice. Okay. The probability is highest for outcome of dash. For what outcome the probability is highest? For what outcome the probability is highest? See, you are getting outcome. That is, what is the outcome here, sir? The sum is considered as the event, sir. Okay, sum is considered. Okay. The outcome is considered as sum. So now the question is, the probability is highest for what sum? For what sum? This probability is highest, more. See here, if you observe, for each number, denominator is 36 only. Numerator is changing. See, when you get more probability, Babu, when you get more probability, Babu, for what number the probability is highest? When you get more probability, denominator is same. So how you compare? So it is like, 1 by 36, 2 by 36, 3 by 36, 4 by 36, 5 by 36, 6 by 36, again 5 by 36. Denominators are same. So which number or which probability is highest? How to identify? Whatever numerator is higher, that is the highest probability. So this is highest. This is the highest probability. So probability is highest. Which probability is highest, sir? 6 by 36. For what number the probability is highest? For number 7 the probability is highest. And if we ask for what numbers the probability is least, for 2 and for 12 the probability is least. Please note that. Now, instead of asking questions about only dice, see here we consider 2 dice, Babu. We can also consider 3 dice. As I told you, I am going to give you that in the comment, that particular video which already given long back. So I'll give you that link. Okay, you can just go through that, where I explained how to find favorable number of cases when 3 dice are rolled for different sums. So what are the possible sums, are from 3 to 18. For each sum, what about the favorable number of cases, how to find it? There is a video. I'm going to give you that in the comment section. Okay, please go through that. Now this is about, coins. If 3 coins are tossed simultaneously at a time, find the probability of getting 3 heads. Coins are tossed. See, when 3 coins are tossed, total number of possible outcomes. See, first coin, second coin, third coin. On the first coin, head tail, 2 possibilities. On the second coin, head tail, 2 possibilities. On the third coin, head tails, 2 possibilities. So for each of the 2 possibilities on the first coin, there are 2 possibilities on the second coin. For each of these 2 into 2 possibilities on the first 2 coins, there are 2 possibilities on the third coin. So 2 into 2 into 2, how much? 2 cube, that is 8 possibilities. That is true. Now, out of these 8, he is asking what is probability of 3 heads. Okay. See, what are the 8 possible outcomes? If you want to understand, you can easily see this. There's a method. Okay. You can just write down starting from the last. Total 8, no? You can start from the last. Head, tail, head, tail, head, tail, head, tail. Alternatively, write down head, tail, total 8 because total 8 outcomes are there. Now, again write down, but double the number of heads and double the number of tails. That is 2 heads, 2 tails, 2 heads, 2 tails. Now, again double the number of heads and double the number of tails. That is 2 heads means double of that is 4 heads and 4 tails. 4 heads and 4 tails. Of course, people also use, tree diagram. See, on the first coin, either you may get head tail for each of these two. The second coin, you may get head tail or head tail. Again, for this, you may get head tail. You may get head tail here. Again, for this, you may get head or tail on the third coin. Again, for this, you may get head or tail on the second coin. So, if you write all the combinations, you are going to get these 8 combinations. So, total is 8. You want 3 heads. Where you are getting 3 heads are only one case. You can just see this. Okay, 3 heads you want. 1 favorable out of 8. This is the one case. Head, head, head. Head, head, head. 1 case favorable out of 8. 2 heads and 1 tail. 2 heads and 1 tail. Okay, now 2 heads and 1 tail means what, sir? Here, this is also 2 heads and 1 tail. This is also 2 heads and 1 tail. This is also 2 heads and 1 tail. So, there are 3 such fellows are there. There is no order mentioned. It's not like on the first coin head, second coin head and third coin tail. Nothing like that. He just mentioned 2 heads and 1 tail. So, there are 3 such fellows are there. See, it may be head, head, tail, head, tail, head, tail, head, head. So, 3 such cases are there out of 8. Please note this. Same outcome on all the 3 coins. Same outcome means don't think head, head, head. Tail, tail, tail also same outcome only. So, either it is head, head, head or tail, tail, tail. So, 2 favorable out of 8. Okay. Now, I just want all of you to go through this question. This is a homework. So, tomorrow we start with this question, sir. This is a homework question. I want all of you to try this. Okay. If you get the answer, you can write down this answer in the comment box. Okay. Write the answer in comment box. Actually, here only one question is there, but I want you to answer the 3 questions. First one is, what is the probability that a randomly picked child belongs to a family with 2 children? A randomly picked child belongs to a family with 1 children. And third one, randomly picked child belongs to a family with 3 children. I just changed the same question. This is the question 1, but now I change it. Here instead of 2, I am giving 3 children. Instead of 3, I am giving 1 children. So 3 questions. So try all this. This is one more interesting question. Very, very important question. Okay. Write down answer for this in the comment box. Write answer in comment box. So we are closing today's session here, and tomorrow we start with combinatorial probability. That is probability using counting techniques. A quick review of all the counting techniques will be done. Okay. So we start with basic addition theorem, multiplication theorem. Then we also have this permutations and combinations without repetitions. Okay, with repetitions also, with constrained repetitions, permutations with constrained repetitions, all this. Okay, maybe we may do it in 2 sessions, sir. So tomorrow we start this. Okay, tomorrow we start this. Okay, that's all for today. Thank you. If you have any questions, you can write in the chat box, Babu, or in the comments. Okay, please share this session, and from today we are going to continue with this probability. Okay, once we complete probability part 1, probability part 2, probability and statistics. It should be better called it as probability and statistics. Earlier, even though they mentioned it as probability and statistics, I always used to call it as only probability, because mainly it is study of probability. That is probability, basic probability and probability distributions we are going to discuss. But here definitely statistics we are going to discuss. Okay. Actually, please note one point. Probability is part of statistics. Statistics is not part of probability. That is a point to be noted. Okay. That's all for today. If you have any doubts, you can ask me, sir. Okay. Thank you.